Welcome everybody to our next video on parabolas. And so again, just to kind of review a little bit, we'll be looking at our forms for our parabolas. So first of all, we had our standard form, which was y equal to ax squared plus bx plus c. Then we had vertex form, which would look like y equals to a times the quantity x minus h squared plus k. Then we had factored form, which looked like y is equal to a times the quantity x minus p times the quantity x minus q. And it's this guy, this is the one that we're going to be interested in today. So what is it about factored form? Well, if we take a look at it, we've got y is equal to a times the quantity x minus p, x minus q. What kind of geometric information does this give us? Well, kind of looking back at our parabolas again, one thing that we happen to notice is that, remember, we've got our roots of our parabola here where we cross the x-axis. So our roots, our x-intercepts, sometimes they're called zeros. Any of those three terms are kind of familiar common terms to refer to these 2 points where we happen to cross the x-axis. Now, the important thing about factored form is that factored form tells us the roots immediately because of something called, and this is the big thing, this thing called the zero factor property. So, good question, what exactly is the zero factor property? What does it say? And how do we use it? Well, let's take a look at that. So the zero factor property actually says that the only way that we can multiply two numbers together and have that be zero is for one of the numbers to actually have been zero to start with. Now, kind of in mathematical symbols, what that's really saying is that if we start with two things that look like a times b is equal to 0, then the only way that can happen is for either one of the a to have been 0 or b to have been 0. Well, that's kind of something that we probably could have guessed at from all of our experience with multiplying numbers together. We know that 0 times anything is going to give us 0. And so the only way to get 0 is for one of those numbers to have been 0. How do we apply that to our parabola situation? Well, with factored form, suppose that we had an example that we had something that looked like y is equal to x minus 2 times x plus 3. Well, if we look at the x-intercepts, that's the same thing as saying that y was going to be 0. So if we take 0 and plug it in for y into this equation, what happens is that we actually get 0 is going to be equal to x minus 2 times x plus 3. Well, here are two things. X minus 2 is representing one number. X plus 3 is representing some other number. We're taking those two numbers, we're multiplying them together, and that's equal to 0. Well, the only way that can happen is for one of these two numbers to have been 0. So what that means is that whenever it's in factored form, we just take each one of those factors, set them equal to 0. So we've got x minus 2 is equal to 0, or we've got x plus 3 is equal to 0. And so those equations are much easier to solve. If x minus 2 is equal to 0, then we know x has to be 2. Or x plus 3 is equal to 0 means x is equal to negative 3. And so our x-intercepts is really just going to be these numbers that we have here, kind of with the signs changed, because we're setting them equal to 0 and we're solving them. And so how this kind of applies in general to our quadratics with our factored form, that looks like y equal to a times x minus p times x minus q. Our zeros, our roots, are really just going to be x is equal to p and x is equal to q. So again, where does our a come into this thing? Well, just as a little bit of a reminder, if a is positive, that tells us that our parabola is opening up. If a is negative, it means that our parabola is opening down. And so from the quadratic formula, we can really have a way of going from standard form to factored form immediately, because that's exactly what the quadratic formula gives us. It gives us the roots of the quadratic. And so if we've got something that looks like y is equal to x squared plus 5x plus 6, With any standard form, we identify what a, b, and c are. So a is 1, b is 5, c is 6. Then with our quadratic formula, we compute the discriminant d being b squared minus 4ac. And so that's going to look like 5 squared minus 4 times 1 times 6, which gives us 25 minus 24, or 1. Taking the square root of our discriminant, we get the square root of 1, which is just 1. And finally, for our roots, we've got x is equal to negative b plus the square root of d over 2a, and negative b minus the square root of d over 2a. Well, plugging in a, b, and c, that's going to give us a negative 5 plus 1 over 2 times 1, which is a negative 4 over 2, or negative 2. For our second root, we've got negative b minus the square root of d over 2a. It's negative 5 minus 1 over 2 times 1, which is negative 6 over 2, or negative 3. Our factored form, then, is really just something that looks like x plus 2 times x plus 3. Essentially, all that we're doing is we're taking those roots that we found, and when we turn those roots into factors, we're really just changing the sign on the root. So we go from a negative 2 to an x plus 2. We go from a negative 3 to an x plus 3 as our factor for that. Let's look at another example and kind of take it through from start to finish. So suppose somebody gives us y is equal to 2x squared minus 9x plus 4. Well, again, identifying our a, b, and c, we've got a is equal to 2, b is equal to negative 9, and c is equal to 4. Computing our discriminant, b squared minus 4ac, we've got negative 9 squared minus 4 times 2 times 4, which gives us a value of 49 for our discriminant. Taking the square root of the discriminant, we get the square root of 49, which is just going to be 7. And then our roots are just going to be negative b plus the square root of d over 2a, which gives us a negative of a negative 9 plus 7 over 2 times 2, which gives us 9 plus 7 over 4. 9 plus 7 is 16 over 4, so we get a root of 4. Well, when we take that root and turn it into a factor, our factor just becomes x minus 4. For our second root, we've got negative b minus root d over 2a. And so that's going to give us a negative of a negative 9 minus 7 this time over 2 times 2, which gives us positive 9 minus 7 over 4, 2 over 4, which gives us 1/2. And so again, when we turn that root into a factor, it just becomes x minus 1/2 as the factor. And so our factored form then is going to be y is equal to 2 times the quantity x minus 1/2 times x minus 4. And so now, what if we wanted to check our answer? Is there some way to then go back from factored form to standard form? Well, absolutely we can. And if we wanted to do that, to go from factored form to standard form, we do that with just polynomial multiplication. And so kind of looking at the examples that we just did, we started with y is equal to x squared plus 5x plus 6. We said that our factored form was going to look like x plus 2 times x plus 3. Well, if we multiply out those polynomials, so we use our FOIL on that one, we're going to start with our y is equal to x plus 2 times x plus 3. Well, x times x is going to give us x squared. X times 2 is going to give us 2x. Our outside terms, x times 3 gives us 3x, and 2 times 3 gives us 6. And so we've got x squared plus 2x plus 3x plus 6. We can combine those two like terms, 2x and 3x, to give us x squared plus 5x plus 6. And that is exactly what we started with, and so we've gone full circle from standard form to factored form back to standard form. So let's try that with our second example that we just did. We started with y is equal to 2x squared minus 9x plus 4. We converted that into factored form. In factored form, that's going to give us our y is equal to 2 times x minus half times x minus 4. Well, again, polynomial multiplication, we FOIL out those two terms. And what we have then is x times x giving us x squared. We've got 1/2 times x giving us a minus 1/2 x. Negative 4 times x to give us a minus 4x. And a negative 1/2 times a negative 4 giving us a positive 1/2 times 4. Well, if we want to combine those like terms, one thing that we can do is get a common denominator, so our 4 becomes 8/2. 1/2 times 4 is just our 2. Now combining like terms, minus 1/2 minus 8 is going to give us x squared minus 9/2 x plus 2. Now if I take that 2 and distribute it across all three terms, that is going to give me 2x squared minus 2 times 9/2 x plus 2 times 2. Well, kind of simplifying that, 2x squared, and then 2 times 9/2 is going to give us a negative 9x. 2 times 2 gives us 4, and so we're back to our 2x squared minus 9x plus 4, which is exactly where we started. And so even on this one, we've gone full circle to go from standard form to factored form, back to standard form, and we're right back where we started. And so again with these, now I hope this has been insightful, give you a couple of examples on how to change forms from standard form to factored form and back again. So hope to see you all again next time.